Lesson 36, Writing and Solving Proportions. Some vocabulary words. Similar. Similar means the same shape, but different sizes. So you can have the same right triangle, but maybe one's a little bit bigger. And anytime you see this wavy symbol here, that would tell you that that is similar. So if they have a triangle, if they name a triangle like ABC, and then they use this symbol, so if they said triangle ABC is similar to triangle DEF, this symbol in the middle here, that tells you that it's similar. Same shape, but different sizes. Congruent means it's the same shape and the exact same size, so they are identical. So they might have triangle ABC, and they'll use the swervy line plus the equal sign, triangle DEF. That would mean that it's congruent. And then we're going to be looking at scale factor today. A scale factor is just the ratio of a side length of a figure to the side length of a similar figure. So the scale factor, the sides need to be proportional. And so you're dealing with the same side of both shapes, similar shapes. And then the drawing scale is just a drawing that reduces or enlarges the dimensions of an object by a constant factor. Okay, so if you have a picture, or if you have the real thing, and then you have a drawing scale, you're either making a smaller version of that or a larger version of that. And then we have a scale, and the scale is just the ratio showing the relationship between a scale drawing and an actual object. So how much bigger or how much smaller would it be? You'll also be dealing with, if you're looking at a map, there's always a map scale, and they will say like 1 inch is a certain amount of miles. And so when you're looking at a map, it may look like it's only 1 inch away, but that could be 500 miles in real life. So those are the vocabulary words we're going to be working with today. So let's take a look at our first example. Finding measures in similar figures. So PQRS, so figure PQRS is similar, because there you see your little swervy line, similar to WXYZ. And just to let you know, the order does matter. So P is in the same place as W, Q is in the same place as X, R is in the same place as Y, and S is in the same place as Z. So we want to find the measure of angle Q. Angle Q is right here. And if we look at the same angle in the smaller shape, that would be X. And similar shapes have the same exact angles. So if we're looking at this angle, angle Q, that angle has to be exactly the same measurement as angle X because they are in the same place and they are similar shapes. So I would just have to look at X, and X is 80. So the measure of angle Q has to be 80 degrees as well. And then the measure of angle W, we go over and find where W is at. W is over here. That's in the same location as P. If P is 120, then W has to be 120 degrees. So when you have dealing with similar shapes, you're looking at the angles and the sides. The sides are proportional, but the angles are exact. So now let's find the scale factor of PQRS to WXYZ. So when we find the scale factor, we need to find the side length that is given for both shapes. It has to be the same side. So I know that PS, we are given what PS is, and that is 3. This is the same side, WZ, in the smaller shape, and we were given that one as 2. So I can say it is 3 to 2, or you can write it as a fraction 3 to 2 that way. So that one has a scale factor of 3 to 2. We are now going to use that scale factor to find our missing side lengths. So it's 3 of the big one to 2 is the small one, is the same thing as find QR. QR is right here. A of the big one, and we have to go to the corresponding side of the small one, which is right here, 5. And then we can cross multiply and divide. So that's 15 equals 2 times A, which is 2A. To get A by itself, we divide by 2. So A has to be 15 halves, or you can write it as 7.5. And then WZ, we still use our same scale factor, 3 in the big figure, 2 in the small figure. It's the same thing as W or YZ is down here. So B in this, it'd be a 6 in the large one as B in the small one. So you gotta make sure that you're putting the ratios together properly. So if you're choosing the bigger shape first on top, then you have to make sure the bigger dimension is on top in both ratios. All I need to do is cross multiply. So 3 times B is 3B equals 2 times 6, which is 12. To get B by itself, divide by 3. B has to equal 4. So we just used the scale factor to find the missing side lengths of our figures. Next one, triangle ABC is similar to triangle LKM. Find angle K. K is right here. The corresponding part or corresponding angle in the larger one is angle B. And we're told that angle B is 25. Therefore, K has to also be 25 degrees. And then angle C is here. Corresponding angle from angle C is angle M. And we're told that angle M is 20. So C has to be 20 degrees. Next one, find the measure in similar figures here. We have two similar right triangles. We want to use the scale factor, find the scale factor, and then find out what x is. So again, with the scale factor, we look at all of our sides, and we want to find the side that we know the lengths of for both shapes. And we know that this side is 5, and the corresponding on this triangle is 3. So we're going to have a ratio of 5 to 3. That's our scale ratio, our scale factor. And then we need to find x. So 5 in the big triangle as 3 is a small triangle is the same as x of the big triangle as 5 in the small triangle. Then we cross multiply. 5 times 5 is 25 equals 3 times x is 3x. To get x by itself, we divide by 3. So we have x equaling 8.3 repeating, or you could just keep it as a fraction. We can make that as a mixed number. It'd be 8 1/3. Next one, how to use similar figures to find the unknown length. So we're using the indirect measurement. So when you're looking at something from a distance, but you know the height, or you know, here we're looking at the shadow length of both figures. If you know 3 out of the dimensions, you can use scale factors to figure out what the missing dimension would be. So here we need to use corresponding parts. So we both know the length of the shadow. So the shadow of the tower is 10, and the shadow of the person is 4. That is the same thing as we need to find the height of the tower as the height of the person. So make sure you set that up properly so it knows that you are using the scale factor properly. Now all I need to do is just take cross multiply. So 10 times 5.5 is 55 equals 4 times x is 4x. I can divide by 4 on both sides. And then I'm left with 55 divided by 4. 55 divided by 4 equals 13.75. And that would be the height of the tower. Now, one other thing you could have done with this 10 over 4, you could have reduced that and done 5 over 2. Could have done that. You will still get the same answer. It just would have been 5 times 5.5 divided by 2. But you'll still get the same answer. But I just wanted to share with you that you could also reduce the ratios there. Next one. How tall is the radio building? So the height of the radio building to the height of the person is 5, as the shadow of the building is 21, as the shadow to the person is 4. And I can cross multiply, so x times 4 is 4x, 5 times 21 is 105. To get x by itself, we divide by 4, and x equals 105 divided by 4 gives us 26.25 meters. So again, we're just using our scale factor, but you also notice that we're still using the golden rule of algebra. Whatever we do on one side, we do on the other. Now let's look at some scale drawings. A desk is designed to have 3 drawers on the right side. In the scale design drawing, the width of the drawers is 4 centimeters. If the scale of the drawing is 1 centimeter to 7 centimeters, how wide will the actual drawers be? So we have a drawing of the drawer of the desk, and then we have the actual desk. So we've used the scale factor. The scale factor is going to be the drawing to the actual, as the drawing is to the actual. And we're using the scale factor. The drawing is 1 centimeter. The actual is 7 centimeters. And we're told that in the scale design drawing, the width of the drawer is 4 centimeters. So I'm going to put 4 on the top because that's the drawing. We need to find the actual width of the desk drawer. So I'm going to use x centimeters here. So now to solve this, I cross multiply. 1 times x is x. 7 times 4 is 28. So we would have our answer, the width would be 28 centimeters. Next one, in a scale drawing, a kite is designed so that the length of the tail is 9 centimeters. If the scale of the drawing is 1 centimeter to 10 centimeters, what is the length of the actual kite tail? So we will do the drawing as to the actual, as drawing is to the actual. Now let's fill it in. The drawing, the length of the tail is 9 centimeters. And the actual, we don't know what the actual is. So I'm just going to put the A. But we know that the scale factor for the drawing is 1 centimeter to 10 centimeters. So if I cross multiply here, I have A times 1 is A. 9 times 10 is 90. So it would be, the actual tail would be 90 centimeters. And the next one, the scale drawing of the kitchen tabletop has dimensions 5 inches by 2.5 inches. if the scale of the drawing to the actual table is 1 inch to 18 inches, what are the dimensions of the actual table? So the drawings. Again, we're using drawing is to actual as drawing is to actual. And the drawing, we got to do one dimension at a time. So the drawing has 5 inches as to, we don't know the actual, but the scale ratio, or the scale factor is 1 inch to 18 inches. So to find the actual, cross multiply, A would equal 5 times 18. 5 times 18 would be 90. And then the other one, we would use 2.5 over the actual, it's the same as 1 over 18. Cross multiply, A would equal 2.5 times 18 is 45. So we would say the length is 90 inches and the width is 45 inches. Those would be the dimensions of the actual table. Now let's look at what happens to our dimensions when we are changing from one dimension to another. So we're going to fill in the chart based on a 1 cube, which is 1 unit. So if the length of the edge of a cube is 1, what is the perimeter of the base? And the base is a square. So if I add up all the sides of 4 sides, each one has 1, that would give me 4 units. The area, I would take the length times the width, which is going to be 1. And then the volume, length times width times height, 1 cubed. So this is 1 squared. This gives me 1. 1 cubed would give me 1. What if we change the length to 2 units? Perimeter of a square, I have 4 groups of 2. So 2 times 4 would be 8. That would be our perimeter. The area of the base, so that would be 2 squared, which is 4. And then the volume, each side is 2. That would be 2 cubed, which would be 8. And then the side length units, we are going to be taking, each side is 3 perimeter, so 3 times 4 would give us 12. The area of the base would be 3 squared, which is 9. And then the volume would be 3 cubed, because we're dealing with 3 dimensions. 3 cubed would be 27. So what is actually happening here? Well, when you take a scale factor and you're going from one dimension to another, the scale factor, the difference from one area to another, when you're increasing or decreasing it, you are actually squaring the scale factor. And with volume, you'd be cubing the scale factor. So let's look at an example here. A dartboard is composed of concentric circles. The radius of the smallest circle, inner circle, is 1 inch. And with each consecutive circle, the radius increases by 1 inch. What is the ratio of the circumference of the 2 inner circles to the circumference of the outermost circle? So the ratio, circumference of the 2 inner circles to the circumference of the outermost circle, so the inner 2. So the circumference of the 2 inner circles, we have pi times the diameter. If this is 1, this is also 1, so the diameter would be 4. So it would be 4 pi over the diameter of the outermost circle. So the outermost one, so we have 1, 2, 3, 4, 5. So this is 5. So that means the diameter has to be 10. So 10 pi. And if we reduce that, pi's cancel each other out. And then I can divide this by 2 halves and end up with 2 over 5. And that would be the ratio of the circumference of the two inner circles to the circumference of the outermost circle. Next one, the dartboard is composed of concentric circles, so this is the same thing, same one, but the difference here is now we want to compare the area of the two inner circles to the area of the outermost. So the area of the innermost, area of a circle is pi times radius squared. So pi times the radius squared, so the inner two, the radius would be 2, so 2 squared over, and then we have the radius of the outermost circle would be 5, so 5 squared times pi. If we simplify this, this would be 4 pi over 25 pi. Simplify, the pi's cancel out, and we would have a ratio of 4 over 25. And our last one, small toy cars are constructed using the scale factor of 1 inch to 64 inches. What is the ratio of the areas of the toy car and the actual car? So the ratio of the areas of the toy car and the actual car, so if the scale factor is 1 to 64, I just need to square both of those because we're dealing with the areas. If I square those, I have 1. 64 squared would be 4,096. So that would be the ratio of the areas of the toy car to the actual car. So that is our lesson on scale factors today.